Welcome to qnawire.
Now this question we want to plot the Fermi distribution function given as such, right? But we want to plot it against E over EF. So the fraction of the energy with respect to the Fermi energy. Now we actually substituted in over here TF, right, which is defined as EF, the Fermi energy, divided by the Boltzmann's constant. So it is still a constant. And we want to plot this curve across various values of E over EF for different values of t. So we want t to be 0.1 times of TF, and we want 0.2 times of TF, 0.5 times of TF. So to generate all these values in the Excel or some spreadsheet should be quite simple. We first have to substitute in these values into this expression of t, right? And then we go in multiple steps, right, of maybe 0.1 for E over F. So we start from 0 to 0.1, 0.2, so on and so forth until about 1.5. Right, these are the values for EF. We substitute that in and get our values of FE, which is the distribution function, right? The Fermi Dirac distribution function. We should get certain values for each of these EF for a particular t. Say this is equals to 0.1 TF, and then we have another set for 0.2 TF. Now we start off drawing the function. I'm just going to sketch out for you what the function you should get. So for t equals to 0, now this is the case where our exponential term over here goes to actually negative infinity. And it can go to negative infinity or 0. So when E over EF is less than 1, this will be negative infinity. And when E over EF is more than 1, then this will become 0, right? Because this will become positive infinity, this will be 1 minus infinity, so this entire thing, 1 divided by infinity, so this will become just 0. So this is actually a very straightforward curve. It goes straight down to 0 once it bypasses the point when E over EF is 1. So this t equals to 0. For the second function, when t equals to 0.1, should get something like this. This is t equals to 0.1 TF. For 0.2, And finally for 0.5. Now you should see a pattern that is actually arising. That is, they all start off at near 1 and then they decrease down, and when they reach the point when E over EF is equals to 1, that is, the energy is the Fermi energy, right? When E equals to EF, it cuts the point at 0.5, right? There's equal distribution. There's a 50-50 distribution of population above and below the energy. So there's 0.5 at this point, regardless of whatever temperature that you are at. But of course, at a higher temperature, the curve starts to flatten out, so you no longer get a sharp decrease near the Fermi energy, but rather it is a gentle, becomes a gentle slope.